So talking a little bit about the engine in InfoWorks ICM, like I mentioned towards the beginning, we do have the swim engine, and you can certainly go to EPA Swim's website, look at the manual for how exactly that's done. Like I mentioned, ICM has the proprietary engine as well that is doing the same thing. It's solving the full solution set of the St. Manon equations. It just does it a little bit differently, and some of those differences are the fully implicit numerical scheme, parallel processing. For 2D simulations, you're able to utilize the GPU card as long as it's CUDA enabled, which most engineering computers will probably have a decent one just because they're running things like Civil 3D and ArcGIS that need some of that. And then also the cloud simulations, you're not having to use your own hardware, you're not having to maintain that, a lot less IT overhead, and being able to leverage all the best processors for that job. So for people who might not be familiar with 2D hydraulic simulations, I've got a comparison of the one-dimensional and two-dimensional here on the screen, where the left side, it is a 3D view of a one-dimensional model. So each one of these cross-sections, if you're familiar with HEC-RAS, you should probably recognize this, where each one of these lines is representative of a cross-section. And then at each one of those cross-sections, that's where the calculations are taking place. With a 1D model, you are making a lot of assumptions that along that line, all the water surface is the same, velocities are the same throughout it. And that can be a safe assumption for many applications, but it's not always. On the right side here is kind of a depiction of the 2D modeling, where each one of, where in general with a 2D model, you'll have some sort of grid setup. InfoWorks uses a triangular mesh. This is just a square mesh just for kind of demonstration purposes, but the idea here is you have flow based on the gradients between each one of these cells. You have some certain amount of flow going in. There's some water balance stuff that takes into place, and so this allows water to go both in the Y and X direction, versus in this type of 1D model, water is only moving in the X direction. Some of the overlap between the two, like I mentioned, you have that uniform water surface elevation in the 1D models, as well as the uniform velocity across it. And the cross sections are typically taken parallel to flow. So again, there's some applications where some of these assumptions are safe, but when velocity isn't considered to be uniform, or if there's issues with that, that's where a 2D model can be really beneficial. The overlap between the two being those mathematical governing equations, the St. Manon or shallow water equations. I like to use this as a picture of kind of understanding in a situation where a 2D model might be better. So if you've ever noticed in a river, we have deposition on the inside of the curve, and we have erosion on the outside of the curve, and that's because water is moving faster along the outside of that versus the inside. Typical one-dimensional analyses is going to have a cross-section similar to this, where again you're assuming that the velocity over here and the velocity over here is going to be the same on both sides of the river, when in reality it's not. It's really going slower, and that's what's causing the deposition on the inside of the bend, versus it's going faster on the outside of the bend. This can also be helpful for situations like the picture on the right, where you have a lot of different flow paths. And again, if you were to create cross sections and cut those across, you'd be assuming that the water surface elevation would be and the velocity would be the same in the larger part of the channel, as well as some of these other bifurcated areas over on the right there. So just wanted to give a quick overview of that in case anyone's not familiar. So with the 2D and being able to use the GPU card to accelerate things, we did some comparisons between HEC-RAS, XP Swim, which is another Innovyze product that is in a mature state, with some different add-ons there, and then also comparing that to a similarly built InfoWorks ICM model. As you can see from here, pretty significant differences between what you're able to achieve with HEC-RAS, and then also some of those legacy products that I mentioned, XP Swim and some of the add-ons associated with it, all of them still being beat by InfoWorks ICM there. CPU versus GPU. This was using the same models, but just using either solely the CPU or adding in the GPU. It's about 12 times faster. It was pretty straightforward with that one to be able to see some of the differences there. But as you can see, if you're using a software that's only able to use the CPUs, leveraging the GPU card can be pretty significant. Function and features here. So we'll look at this. So really just visually rich. This one's a neat one, looking at a two-dimensional model. So you see those triangular mesh elements there. And this is, of course, exaggerated in terms of the elevations, but can make it really neat to be able to view information, just get better idea of what's going on. You can also put the simulation through here, be able to see the flooding and things like that. We also have, whoops, didn't go that far. We also have thematic mapping in here, so being able to extract information that we might typically want to see in a model. Also being able to use those across different projects. So if there are particular things that people want to see or results that they want to review, they can set up a theme to be able to view that using reports and otherwise. Of course, we have all the typical types of views, whether it's a plan view, a profile view, graphical representations of different metrics, as well as tabular results. All of that can be seen here. And if you notice, the thematic mapping is being maintained between the profile as well as the plan view there, and it is dynamic to the simulation as well, or can be unique to the simulation. So, and then yeah, I guess we got the export floodplains, but second to last here is SQL queries, being able to use the structured query language to be able to extract results, whether it's just common things that people like to see. It can be used to highlight where issues are in a model. These can also be very useful for manipulating the data. So you can actually write something to modify database objects. This can be extremely beneficial in time savings whenever there's a situation where you're doing some kind of mundane task or similar task. You can usually write a script to make that modification much quicker than what you would do by hand.